Hey everybody, and welcome back to Front-End Expert. In this video, we're going to be discussing closures within JavaScript. So if we look at this example here, we have this constant global num that's set to 5. And then we have the function lognum, which has its own constant local num, it's set to 1. And then we console.log global num plus local num, and we call the function down here. And you can see in our output, we get the number 6. So what's happening here? This is what we call lexical scoping, which simply means that functions have access to their parent's scope. So when we console.log global num plus local num, the function lognum has access to this global num variable. And if we were to change that variable, so let's make this let instead of const, if we were to say global num equals 10, then it's going to see that change because it is looking at the actual global variable. It doesn't have a copy of this variable or anything like that. It is looking at this global variable that is in scope to this function. This idea is known as a closure. A closure means that there's access in a function to the outer scope within the inner function. And this is created when the function is declared, not when it's called. So more formally, a closure is a function. So for example, our lognum function plus the lexical environment it was declared in. This environment simply holds the local identifiers, such as local number being set equal to 1, and it has a reference to the parent environment. So the environment where this function was declared. In this case, it was declared in the global scope, so it also has a reference to that parent global environment. So when the function is executed, it's going to use the local scope first. And then if it can't find an identifier it's looking for, such as this global num, then it's going to look in the parent environment, in this case, the global environment where it finds the variable global num, and that's the number it will use. And for many of you, this might just seem natural. It might just be putting a name to the expected behavior of a language, but this isn't actually how every programming language works, and there are some unique features of it in JavaScript. So let's look at a more concrete example. I'm going to remove this code here, and let's create a new function. So let's say function, and I'll just call it example. And then inside of the function, let's declare a constant. So let's say num is equal to 5. And then inside of this function, let's declare another function. So let's say function lognum. Now this function lognum is going to create a closure at the time it is declared. So when we get to line 4, it's going to create a closure which keeps access to the variables of the example function because this is inside of its lexical scope, or the lognum function is nested inside of the example function. So now inside of lognum, we could say console.log num, for example. And now we can simply call lognum. And then let's call example outside of the example function. And we will do what you expect. We log 5. And we can actually have conflicting values. So what if I had a parameter to lognum? Let's say this was also called num. And then we pass in the number of 10. Now, what's going to happen here? It's actually going to log out 10. The reason being that the lognum function has its local scope, which has this number variable. So when it runs console.log num, it finds the identifier num in its local scope, so it never needs to look to the parent environment. Instead, it just looks to its local environment, and it never uses the value of the const num equals 5. Okay, so now let's remove the num local variable here, the parameter, and let's return this function. So let's say return the function and never call it. So we don't need to give this a name either. We can just return an anonymous function. And now when we call example, this is going to be the function. So let's save that function. So const inner function, and we can set this equal to example. And now if we call inner function, what's going to happen? Well, it's actually still going to work. It's going to log 5, which is interesting because the example function has already run and its execution has completed. So in many programming languages, the number 5 would be garbage collected at this time because example is done running. But in JavaScript, it creates a closure. So this function creates a closure and it keeps access to its parent's scope. So that means that the const num that was declared in example is going to exist as long as this inner function exists, because of the fact that we need that num equals 5 value to be able to run the inner function. It is part of its closure. Now, there are actually some pretty useful applications of closures. One of the most common ones is going to be private methods. So let's get rid of this code for a moment and let's create another function, and let's call this make functions. And this make functions function is going to return an object, and this object is going to have a few functions. So one, it's going to have a log num function, and let's just say that this calls console.log of, let's create a private number. This is going to work sort of similar to having private fields in a class in another language, and we can actually do this in JavaScript now as well, but it's not super well supported by browsers just yet. So this is a more traditional way to do it. So we can say const, well, actually, let's declare this with let private num, and let's set it equal to 0 for now. And then we can also add one more value to the return. So let's add an increment function. So we can call this increment, and let's make this an arrow function as well, but this one will do two things. So it's going to call a private function. So let's call private increment. And let's also console.log incremented. Okay, so now we need to define the private increment function. So let's say function private increment, and all we're going to do is increase private num, so increment it by 1. And now what we have here is a function make functions that is just returning some functions. So you can think of these as like our public functions. And then we have private increment and private num, which are private to the make functions scope because nothing is giving access to them externally. However, log num and increment do have external access because they are our return values. So now what we can do is we can say const, and we can use destructuring syntax here. So we can say log num and increment, and we can set this equal to a call to make functions. And now we can say log num, and you'll see we log out 0, which is logging out this variable that existed in the scope of make functions. But we couldn't just say console.log private num because this is no longer in scope. Its scope is just the make functions function. So even though private num exists in the log num closure, we can't access it outside of that closure because it would be out of scope. And of course, we can also call our increment function and maybe log num one more time. So we will end up logging 0, then we say incremented, and then we end up logging 1 in the second call to log num. And one more thing that's interesting is that this private num value and private increment for that matter, and all of these values that are part of this closure become local to the environment created at the execution time of this make functions. So let me show you what I mean. Let's do this one more time and have two versions of make functions. So I will call this one log num2 just so we don't have two variables of the same name. And then I will call this one increment2. And now if we come down here and copy this code, and we can say log num2, increment2, and log num2, you'll see what happens is we have two separate sets of variables. So we still had 0 incremented and then 1, but then when we log 2, num2 is still 0 because it is a separate variable. So log num has access to a different num variable than log num2. The reason for this is that they were created in different calls to the make functions function, meaning that log num and log num2 have different parent environments. Each of these calls created its num variable, which was then saved in each log num closure, which in turn gave them separate variables. Okay, so now let's take a look at one last example, and this is going to be a very common example that can oftentimes come up in technical interviews, but it's also just good to use as a way to check your understanding of this concept as well as a few others. So let's create a for loop. and I'll say let I equals 0, and then we're going to say I is less than, let's say 3, and then we'll do I plus plus. And for now, inside of this for loop, let's simply console.log of I. Okay, so now when we run this, as you might expect, we get the values 0, 1, and 2. Okay, so now what I want to do is create a set timeout. So let's say set timeout, and inside of this set timeout, we will pass in an anonymous function, and in that anonymous function, we are simply going to copy this code. So we are going to console.log I, and then we can say this will run after 500 milliseconds. Now console.log I is inside of an anonymous function, an arrow function, and this function is creating a closure, which means that it has access to the I variable even after the for loop is completed, 500 milliseconds after it's completed to be more exact. And now when I run this code, we still get 0, 1, and 2. It just takes 500 milliseconds to show up. Okay, but what would happen if I changed let to be var? Well, now if I run this code, what you're going to see is we actually log out 333. So what's the difference here? Well, let is block scoped, meaning that let is only scoped inside of these curly braces. So what JavaScript does when we use let in a for loop is it creates a new version of that variable with each iteration of the loop. So what this means is that console.log I inside of this arrow function, each time it created a closure, because in each iteration of the loop, we created a new function, and each one of those gets a closure. And with let, it was a different variable each time. However, var is function scoped. So in this case, it's just scoped globally because of the fact that we are not in a function. What this means is that we are using the same var I in each iteration. There's no way to create a new version of var I just for the individual iteration of this loop. So we get the same variable each time. So even though we have 3 different closures, they're each pointing to the same I variable. And at the end, we are still doing an I++ at the end, which is why we get the value of 3 rather than stopping at 2. And we can actually show this by after the for loop is over, we can do a console.log of I, and you'll see we end up logging out 3. The reason we log 3 is because var I is still in scope. However, if we did let I, then we're just going to get an error message because I is not defined in this scope. This can be a very common example and it can trip people up a lot. So just know if you are presented with a question like this to think about both the scoping of let versus var, as well as to think about which closures are being created. And remember that those closures are created at the time that the declaration of the function happens, not at the time it is executed. So in this case, the closures are created during the iterations of the loop, even though this function is not executed for 500 more milliseconds. So with that, that's going to be the end of this video on closures. I hope you found it helpful, and I'll see you in the next one.